Hello everyone, I'm Amulya PR from Sri Venkateshwara College of Engineering and I belong to the branch CAC AI. So today I'm back with another video of the subject mathematics and with the subtopic lines of regression and its applications. Now let us look into the contents of what we are going to learn today. The contents of what we are going to learn today are Introduction to Regression Analysis, History of Lines of regression, Types of regression analysis, Example sum on lines of regression, Applications of lines of regression, and its conclusion. So now let us see what regression analysis is. So the main goal of regression analysis it is to create a mathematical model which can predict the value of dependent variable. So the predicted values, so it will be based on the values of independent variables. So this mathematical model it is represented by regression equations. So it is usually in the form of straight line or hyperplane. So regression analysis is a statistical technique used to examine the relationship between the dependent variable and one or more independent variables. So yeah, so basically the mathematical model is represented by the straight line and also it is usually predicted by the dependent variables based on the values of independent variables. So in the topic analysis of regression, today we're going to see of the subtopic lines of regression. So the founder of lines of regression was Sir Francis Galton. Sir Francis Galton was an English mathematician, statistician, and a polymath. So Galton introduced the idea of regression in the late 19th century during his research on heredity and genetics. So heredity and genetics is basically a biological term, and also we can see this natural inheritance book which was published in 1889 by Sir Galton. So this describes the relationship between the heights of parents and their offsprings among other traits also. So by this we can compare the dependent variables with also the independent variables. So this is how Sir Galton founded the lines of regression. So Francis Galton introduced us to the idea of lines of regression, but the term regression was coined by Carl Pearson. So Carl Pearson was another prominent statistician and Galton's protege. So regression analysis has become a fundamental statistician tool. So now it is widely used in the various fields of predictive modeling, inference, and understanding the relationship between the various variables. Now let us see what is lines of regression. Lines of regression is also known as regression lines. So these are the straight lines that represents the best fit relationships between the two variables in a scattered plot. So it basically helps researchers and analysts to understand how changes in one or more independent variables can affect the dependent variable, making it a powerful tool for prediction and inference and also understanding the underlying relationships in data. So it is used to determine these regression lines, which helps uh, to understand the relationship between dependent variable and also the independent variable. So there are two types of regression analysis or the lines of regression. So the first one is simple linear regression line and the second one is multiple linear regression line. So the simple linear regression line is represented by the equation y is equals to a plus bx. So where y is the predicted value of the dependent variable, x is the value of independent variable, a is the y-intercept representing the value of y when x is 0. So b is the slope of line indicating the change in y for a unit change in x. So it is a straight line that is determined by minimizing the sum of squared vertical distances between the data points and the line. So don't worry about this complex sentence. So we are going to understand this when we solve the example sum. So multiple linear regression line is the case where two or more independent variables are in the relationship between a single dependent variable. So The multiple linear regression line is usually represented by the hyperplane. So it is indicated by the hyperplane. So this represents the best fit relationship between the dependent variable and multiple independent variables. So y is equals to a plus b1 x1 plus b2 into x2 plus b3 into x3 plus so on bn into xn. So y is the predicted value of dependent variable x1, x2, and so on up to xn are the values of independent variables. A is the y-intercept when x is equals to 0. b1, b2 up to bn are the slopes of line, indicating the change in y for the unit change in the variable x. So now let us look into how to solve example sum based on the lines of regression. So here we have an example sum with us. So the values of x and y will be given. So values of x and y are represented here. So there are two variables, that is x and y. So the formula for finding out the lines of regression is y is equals to sigma xy by summation of x square into the x. So the formula for x is summation of xy divided by the summation of y square into y. The y can be, represented as y minus y bar. So x also in a similar way can be represented as x minus x bar. So this is these both are the modified formula based on the requirements. So first, when the variable x and y values are given, we need to find out x is equals to x minus x bar, that is x minus x bar, and y is equals to y minus y bar also we need to find. Then x into y, we need to multiply x and also the y. Then we need to square up the x. The x whatever is obtained here should be squared up, and also the y whatever is obtained here must also be squared up. And also we need to find out the summation, the total sum of x, y, and also the x into y, the summation of square of x and the summation of square of y. So the x bar is found out by the summation of x by n. So here n is the total number of values that is given in the question. So we have 7 values. So we've taken the value of n as 7. So 28 by 7, which gives us 4. So similarly y bar is also found out using the formula sigma y, or the summation of y by n. Summation of y we got there as 77 divided by n value is 7, that gives us 11. So now we need to substitute in the formula of lines of regression. So we have two variables which I told earlier, x and y. So for both we need to find out. So we need to substitute in the formula whatever we've obtained in the table, we need to substitute here. So the y bar is nothing but it is 11. So the y bar is 11, and then sigma xy we got is 26. So sigma x square we got 28, and then x bar we got 4. So similarly x bar is 4, and then we've substituted whatever we've got. After substitution we get y is equals to 0.93x plus 7.28. So and for x variable we get it as 0.93y minus 6.23. So these are the required lines of regression that we had to find out using the given question. Now let us see where regression lines are made use in the real life. So it is usually made use in financial analysis, epidemiology and public health, economics and policy analysis, and weather forecasting. In financial analysis, it is used to predict certain values such as stock prices, and also it used to make predictions about the investment decisions. So in health sector, it is used to predict the risk factors and the disease outcomes that will contribute to the public health issues. So in economics, it is used to analysis the policy charges and tax reforms or even the trade agreements also. So in weather forecasting, it is used to predict the values of the environment, that is temperature, humidity, or the atmospheric pressure. Now we have come to the conclusion about the regression analysis. The strength of relationship is, that is the relationship between the independent variable and the dependent variable. So it will be of two types. That is, if the slope is negative, then it will have a negative relationship, whereas the positive slope will indicate the positive relationship. Also, the more steeper the slope, the stronger will be the relationship. The regression lines is used for the prediction. The accuracy of prediction will depend on the quality of model and variability of the data, assumptions and validity. So it is used to check the assumptions such as the normality of residuals, linearity, and also the independence. I thank each and everyone for watching the video completely till the end. I request everyone to please like the video and also share the video with your friends. And also assure to come back with another video of different topic. So till then, have a good time. Thank you.